Is it recording?
I think it is, yeah.
Oh, yeah.
It is a little bit. All right. Hello, everyone. So today I am going to be talking about two things related to Awk. One, I'm going to do an introduction to Awk for those who are unfamiliar with it. And then I'm going to talk about some work that I've been doing. I initially started it about maybe a year, 2 years ago. I guess it was 2 years ago now. I started it around the time of the Systems We Love, when I was putting together my my talk for Awk and the Love Story. And I realized around that time that the Awk that we ship in the platform, Nock, also called the One True Awk, because it is written by Brian Kernighan, I realized that it was rather out of date. And so I started working on putting an update together, and it's been sort of a long saga. So I've stopped and then started, stopped and then started. So Awk, for those unfamiliar with it, is a text processing tool. So using Awk, you can work with and manipulate text, and you can extract data, you can build reports, you can do a lot of different things. Give you an example. I have put together here a simple text file. And you can see it's just 3 columns. Each one has a letter in it. And there's seven records. Yeah, 7 records. And Awk programs are made up of these simple blocks. You have a pattern that acts like a guard and says whether or not to execute the block, and you have a action that you take. So if you do not have a pattern, then all records are by default processed. So Awk will take this input file and it will process it one line at a time, and it will split each one into different fields. By default, it splits on white space. So here we have output that looks like that. So we have printed out the 3rd column from every single row, CFILORU. But you can also omit the block as long as you have a pattern. So here we have just the pattern F. So if we run this, we can see that it just prints out the entirety of the record that matches F. I put together, I'll drop this. In case people feel like I am moving too quickly, there is all the examples that I'm putting together. You can put together more complex patterns. For example, this one will begin matching at the line that has G in it and ends matching at the line that has M in it. If we run this, and we get HKN. So that is the 2nd column from the line that has G to the line that has M. And there are also these special blocks, begin and end, which run at the very beginning of your program and at the very end of your program. We run this one. And we can see we executed the begin block at the start and the end block at the end, and we printed out the 1st column from every single line in between. So a lot of these are very simple usages of Awk, but Awk can do a lot more. And the last time our Awk pulled in from upstream was 1989, which means that a lot of the things that have been added to Awk, and if you are used to using GNU's Gawk, you might expect, are not available in our system's user bin Nock. when I realized this, I thought, well, I should just go in and pull in the latest sources from upstream. However, when I went to go do so, I realized that Sun engineers had fixed bugs in userbin.nock themselves, independently of the fixes that were done upstream, which meant that the two programs had diverged somewhat significantly. So I sat down and I started taking a look at the two. And first thing I realized was someone had gone and C-styled the entire program. So in order to make it easier to compare the two, I went and C-styled the upstream sources so I could see the differences better. Once I did that, I worked my way through each file using BIMDiff, and I started applying some of the more routine changes that had been done upstream to our sources. For example, renaming common macros, renaming common functions. I went through and changed all the unsigned chars to all just be regular signed chars where that had been done. And I slowly worked my way through, copying each of the changes over. I tried to split them up into commits that matched high-level features or high-level bug fixes, and I gave them, so rewinding a little bit, upstream doesn't use source control, not until this summer. Instead, Brian Kernighan preferred to just drop tarballs routinely, which meant that the only thing that indicated what had been changed was the fixes file, which contains all of the fixes he has made over the years, a list of descriptions of each one. So I gave the commits names from the fixes file and started working my way through those, trying to fix them at a time. As the difference between the two programs grew smaller, it became easier to understand what some of the changes were and what significance they had. There were some places where only one line was different in a way that seemed significant, but it was hard to understand at first. But once it grew smaller and all the other noise around it became smaller, it was easy to grasp. While doing this, I realized that I didn't have a good way to tell what impact these changes might have. So I took the test suite that Upstream has, which is just a series of scripts that, given two awk programs, runs each awk program with different input and verifies that the output matches. This isn't really ideal for most testing scenarios because it means that if you accidentally introduce a bug, forget to do the regression testing with something before your change and something after your change, then you'll never know that the output has changed, but in a way that you can't easily detect. So I generated, using GNU's Gawk, a bunch of example output for all of the different cases. And then I committed those and made it so that userbin.nock gets run and compared against that output. I then took all of the tests that were passing and put those into their own commit, and that is currently in the gate. And then the rest of the tests are going to accompany the source code update. That way it's obvious when you look at the commit what behavior has been added or what bugs have been fixed as part of it. I also imported tests from GNU Gawk into the gate. They had much more comprehensive testing, and they also had tests that helped expose bugs that Upstream has. So I submitted fixes for those. So some of the things that were added, some of the new features or bug fixes that you will be able to use once it's in are POSIX character classes. So this is one of the things that I noticed was missing and initially spurred me to do something about it. So if you look here, you can see in the third block that there is this sort of weird character class, square bracket, colon, upper colon, square bracket. These are the POSIX character classes, which are, they basically run, so in libc, you have functions like isUpper, isAlpha, isAlnum, isLower that test whether or not a character is in a certain class. And these are aware of the current locale and handle the handle it accordingly. So if you are using some Cyrillic script, it will behave correctly and determine whether or not it's an alphabetical character or a number. If you're in the C locale, then it only deals with things in ASCII. So in this program, we use the character class to upper to determine whether or not there are words that are all uppercase. And we take them and we collect them and we count them. Then at the end, we iterate over all of the words, and if the word occurs 10 or more times, then we print it out. Another significant thing here is in the begin block, I changed the record separator to be a space so that rather than splitting the records on the new line, we split them on spaces so we can handle every single word individually. We also take the any words that end in a period because they're at the end of a sentence and remove the period. I then have the top 500 posts from our legal advice here. And so we can analyze this text. So some of these are things you might expect. Capitalized A, probably at the beginning of sentences. Don't know what a capitalized C would be. I, referring to someone's self. But we also see ones that seem more likely to be related to legal advice. TSA, MIL, HOA, DNA, HR, IT. We then have one of the new features is the ability to split per character, either on as a field separator or when using the split function. So in this program, we have in the begin block, we have a string which is every letter of the alphabet, and we split it into an array called alpha, and we print out the 13th letter of the alphabet. If we run that, we can see the 13th letter of the alphabet is M. It's important to note here that split and some other similar functions in awk will start indexing at 1. So A is at index 1 and not index 0. One of the things that I ended up implementing myself is GNU awk has this special variable called RT, which is the record terminator. While trying to put together the test suite and do some different things, I wanted to perform some substitutions on files using sed. However, it turns out that the sed in our gate will introduce a new line at the end of files that do not have a new line. So you can perform your substitution and your file will be modified to have the substituted text. But if your file had no trailing new line, it now has one. This wasn't really useful for comparing output because there were some files where it's significant that the white space isn't there. And I thought I'd try putting something together using awk. However, awk has the same problem. You can't determine whether or not at the final record there was a trailing new line. In GNU awk, there is RT, the record terminator. This informs you what the terminator at the end of your line was. Usually, in most cases, this will just be a single character string, \n. But at the end of a non-new line ending file, there is just the empty string. So you can see this in this example. So the length of RT is 0 when it's just A, but it's 1 when there's a new line. We could also print out RT, and that's just a new, it's probably better to do. You can see, in that case, there's nothing. One of the things that is changing in a non-backwards compatible way is the behavior of escaping in sub and G sub. So normally the string that you write is introduced literally into sub. So you can see this in something like A equals H, substitute H with F, and A, print A. That turns into F. If I write \h, I gotta write 2. So if you write \, so you have to escape it twice in order to get through the initial parsing of an awk string into the substitution. So that introduces a literal \h. However, you can also do that. So ampersand will match whatever the matched text was. So if we had hi, what's matched is matched text is H, and so we introduce that using the ampersand. However, you might want to escape that. So that introduces literal ampersand. So sub will recognize the special pattern of escaping. You can see it's exactly the same in the old one. Sub and gsub recognize a special escape sequence just for ampersand and just for backslashes. However, it becomes rather annoying if you want to write multiple backslashes and substitute those directly into your text. So we have this example 4 here, and we can see in the old knock that despite all the backslashes, it only introduces first 1 slash, then 1 slash, then 2 slashes, and 2 slashes. GNU's Gawk changed their behavior. I don't know when, sometime in the late 90s, I think. And Brian Kernighan decided to copy that behavior and introduce it into knock. So that's one of the things that gets pulled in by these changes. So now it is easier to introduce multiple backslashes. Not many people try to do this, but it is a significant change. One of the other new features is the next file keyword. So this allows you, so if you're familiar with the next keyword in awk, it will next skips the current record. So it stops processing the current record, skips any future blocks that were going to be used on this record, and goes directly towards the next record. Next file is similar, but for files. It closes the current file that you're processing, moves on to processing some more. So you can see, for example, we can run on like so if we process all the manual pages under man3 malloc, we can find all the very first occurrences of .th at the start of a line, print out the name of the manual page, and then move on to the next file. Skip any future lines. There might be other lines that might have matched, and we ignore them. We also have the introduction of the safe flag. So in awk, you can use the system function to run a command. So this behaves similarly to system in libc. It runs it using binsh and returns the status code. If we run this program, we can see that it prints out the date. But if we pass the -safe flag, then the program is rejected. This can be useful if you have some untrusted program, or you just are feeling paranoid and you want to make sure that your program is not allowed to run certain commands. Maybe you are accepting programs from someone else in the organization, or maybe you have some kind of internet-facing system that accepts some input that gets injected into an awk program. It allows you to make sure that things do what you expect. One of the things that our knock has not done historically is change. So if there's the special NF keyword, which is the number of fields in the current record. So you can, for example, print out, if you're processing a bunch of fields, you can print NF, and that will print out how many fields were in each record. You can also modify NF to truncate fields. But user bin knock has done this inconsistently and not always updated the $0 record after you change NF. So we can see, for example, with this input, we have A, B, C, D, E in one record and F, G, H, I, J in the second. We can then run that, and we can see that we have changed the number of fields in the record from 5 to 4. And because in our begin block we changed the output field separator, OFS, to be a pipe, we also change what we print. So it's now printed with A pipe B instead of A comma B. The old knock, however, doesn't do anything to the output. And this is somewhat accidental because if you do other things that change internal flags on the record, for example, modifying one of the columns, then it will rebuild it. So all we do is just add this $3 equals H to the program. And then we have ABHD separated by pipes. The behavior will now become more consistent, and modifying NF will change the record. So those are sort of the big high-level things that are new. There are some other things that have already been available that I think are worth knowing, so I'll show them. But if you want to see the entire list of available changes, you can go to RM already shared the link. So yeah, that has all the commits for the update. So if you take a look at that, you can see each of the individual commits. I've given them commit messages named after the fixes, as I mentioned. Some other cool things that I think are useful to know with Awk are the $sign character is, so if you write like $5, that isn't a variable. It seems like one, especially if you're used to languages like Bash or PHP, where $sign is always comes before a variable name. But what it really is the field operator. It allows you to say, I want to access this field, and there's a special field 0, which is the whole record. So in this example program, we can see several different ways that this behaves. So in the block, we print out the whole line using $0. We then iterate from 1 to the number of fields, and we skip all the odd number fields, and we print out each of the even number fields. We can then also print the very last field using $NF, and we can even print the second to last field using $NF-1. This can be useful if you have input that has an inconsistent number of fields, but the value you want is always in the last field or the second to last field. So I know I've encountered this before, where there are some programs where they aren't always consistent about printing some value, but I know that I can always access the third to last field and get the information I want. So we run this on this program, which has an inconsistent number of fields, 5 in the first, 3rd in the second, and 6 in the last. Then we see that it prints out the even number of fields, and it prints out the last field and the second to last field of each line. You can also use the NR value. So there's the NR variable, which is the current record number, and there's the FNR variable, which is the current record number in the current file. So if you are processing multiple files, NR will increment for every single record processed through all of the files, but FNR will be reset every time you open up a new file. Using NR and FNR, we can write something similar to a poor man's WC and count the number of lines. In this program, we initialize last n to the empty string, last l to 0, and we then check every time we hit FNR is equal to 1, whether or not we have processed any previous files, and we print out the number of lines it has. Then on every single line, we can save the current FNR value, and at the end of the program, we can also print out the total number of processed lines. We run this on the R legal advice text. We can see that has 6,896 lines. The number of total lines is the same. If we run this on the malloc man pages, we can see each number of lines that every single one of the files has, and we can see the total number of lines. Example similar to the one we saw earlier for example 1 and example 3 for, oh, I skipped example 3. Well, I'll do it after this. So the next keyword I mentioned skips lines. This allows you to write some simpler programs where you can write multiple blocks that all skip things before you get to a functional block. So rather than try and come up with some complex guard that to help you skip counting certain words, you can instead just write a bunch of next blocks. So in this example, we similarly process every single word in a file, and we normalize the words so they're all lowercase, and then we skip all the short words, and we skip a bunch of common words, and then we sum up the number of occurrences. Then we print out the ones that occur 150 or more times. Running this on the legal advice text, we can see some of the lawyerly words: legal, lawyer, police, people, money, parents. So the example I skipped, one of the new things in the update is you can now use length on arrays. So in this example, we can calculate how many words, unique words there are in the text, by just making sure we save all the words that we care about and then saving them. So if we run this on the legal advice text, we can see there are 16,771 unique words. We can also use this. So the match function will, when used, set two special variables, rstart and rlength. So normally you might just write like, just use slash of the regular expression to determine whether or not a line matches. But using the match function, we can set rstart and rlength, determine where the regular expression started to match inside a string and how long that match was. Using this, we can extract text that we care about inside the string. So in this case, we look for things that begin with HTTPS, and we find all the way up to the first space, or because Reddit uses Markdown, we can look for the closing parenthesis or closing square bracket. Running this on the text, we can see a bunch of different links. The important thing here is that this will not match any lines that have multiple links in it. It will only find the first one. So we could write a variant that looks like that and give it this input. We can see that it works on the different links, whereas the original program only works on the first. Also, if you need to access environment variables from inside an awk program. So in this example awk program, we check that we've been given an argument, that we have exactly 2 arguments. We run this and we don't do anything. Then it exits 2, as you can see from the my status line, and it prints out, please provide an argument to standard error. You can see that by so I could then say, give it the argument SSH. And then what it does is it checks every single variable in the environment, and it checks whether or not the string matches, the environment name, variable name matches SSH. And this shows off one of the things that I think is sort of cool about awk, which is that you can evaluate strings as regular expressions at runtime. So where you're using a string that was given as user input and using it as a regular expression and checking if that matches. So that means that we can do things like that, or this won't find anything, that. If I look for H, I get a bunch of different things. If I look for $, I get all the paths. Some funny things that I came across. There is a special internal variable which you normally can't reference because its name is $0 and null. But there is a special global associative array, symtab, which contains all of the variable names. So 0 and null lives there, and it's normally set to an always 0 value that also matches the empty string. And this is used internally for determining whether or not something is true or false. So by modifying it, we can sort of screw around with the behavior of conditionals. So you would expect 1 to be true. And you would expect this would print out true, but because we have modified 0 and null to now be the value 1, it ends up being false. We undo our modification. It's true again. I thought that was a bit funny. Reminds me of, I don't know if people have heard, but Alex has done similar things with Python before to screw with university students. One other thing that I thought people might find amusing. There were some areas within awk where there's some areas within the old awk where it was using freed memory. So you can see this if we use libumem and umem-debug, and we can see that instead of printing out the string H, this prints out dead beef, feed face, feed face. Memory has been written over by umem. So that's it for things that our NOC has been able to do and can be able to do soon. There's some other things that it won't be able to do, which would be nice. For example, GNU's Gawk has this third argument to the match function, which allows you to create pattern groups within a regular expression and then extract the things that match those groups into an array. That's a non-standard thing that they have. It'd be nice if we had that. It's a pretty useful feature. Prevents you from having to do a lot of fooling around with multiple calls to match and using rstar and rlength multiple times. They also support modifying the environ in the array to change the environment variables, and those are reflected in child processes. If you modify environ in our user bin NOC and then try to run some program, it won't see the modified environment variable. If you want to have the child process have the modified environment variable, you'll have to prefix your command with something that modifies it. That concludes the things I had prepared. Did anyone have any questions about any of it? Did I go over any example too fast? You want me to revisit it?
Sorry, I came in late. You have all these examples. They're available for us to read somewhere, right?
Yes, so I dropped the gist in mid.
Okay, thank you.
Which has them. Yeah. Yeah, it's if you scroll up to 1007. Cool. All right.
107.
What was that?
107 East time.
107 if you're East Coast, yes. Cool. If no one has any further questions, then I suppose that concludes the JTD.
Thanks, Cody.
Thanks, Cody.